안 나오죠? 그냥 껐다 할까요? 오케이. 안 켜지는 것 같은데요? 그냥 할까요? 네. 네? Oh, great. But it's the same before. As before. 바꿨는데. Oh. Okay. Okay. Hello. Good morning, everyone. I'm Soonjo from Team1, and today our topic is analyzing person's routine to predict future occasion. So this is project proposal, and our teammates are Alessandro and Pranjay and Hala, as you can see. So let me start. So this is table of contents, first introduction, and we will show you the goals and then related works, and we will explain the methodology and also possible applications and job allocation, schedule, and reference. First introduction, there are many people who have cognitive impairment, such as intellectually disabled people. For example, people with dementia, like Alzheimer's disease, or for example, babies or children under like 5 or 4, they don't know where they're going or what they are doing. So for those people, there is a higher possibility to get lost because of the periodic confusion or memory loss, especially for the people with dementia. And they are from time to time not recognizing familiar people, like family or places. So we need to predict their past or future location, because as I explained, they just don't remember where, the place they are going and the familiar places. And we can think of this child kidnapping example. For example, in case of child is kidnapped, if we can predict the trajectory of the child was going, then the police can be advantaged by the if there is system prediction system. So in the right figure, you can see there increasing number of people with dementia over age 65. So this is the problem that we are dealing with. So to predict the exact location is the goal of our project. So to support this core goal, we have divided goals into two: core goal and additional goal. So we have two core goals and one additional goal. So first one is designing of the application for collection of the GPS data. And the second is figuring out the correct machine learning algorithms. These two are core goals, and the additional goal is visualizing results on the map. The prediction result, we will plot it on the map. So yeah, this is the goal, and this is our system. So if we input day and time, then the output will be the location of a person who we are interested in. So this is the figure that explains that. So this table shows related works, which is GPS-based prediction systems. So including our project, we found 3 similar papers. Actually, there are lots of papers, but we couldn't include all the papers, but the GPS-based papers. So if you see the purpose of those papers, very similar. They have very similar purpose. For example, all the prediction purpose and transportation routines and travel time prediction and future location prediction, like our study, and they all use GPS coordinates. And to acquire the GPS coordinate, they are using separate GPS sensor or cell tower. In our case, we are using smartphone as a GPS sensor. So they're using various methods, and we haven't determined which method we are going to use. And if you see the figure, this Nokia cell phone is not a smartphone, I think. It says it's kind of warning. You may not see correctly, but it's a kind of warning based on the prediction. It's the first paper, and below is the third paper, and it's the prediction of the trajectory or route or future location of a car or something. So these are similar researches, and we are going to also do the future location prediction. So I will explain our methodology from now on. And our flow goes like this. First, collecting and extracting GPS data, and the second one is machine learning, and the third one is to predict the exact location. So the first one consists of 2 parts: data acquisition and data extraction. First, we will going to use Android smartphone. and gather some GPS data from out of it. And for example, it contains day and time and longitude and latitude and so on. And then we will extract these data from the Android phone somehow. And then we will divide those data into three sets. First one is training data set. Is for training the artificial intelligence. And the second data set is validation data set. And the third one is for test data set. So after that, we will input these data into machine learning model. As I said, we haven't determined which algorithm we are going to use. So there are many algorithms which is provided by TensorFlow or other tools, linear regression, logistic regression, SVM, neural network, and so on. So after training enough, we think we can predict the location. So since we are going to use Alessandro's smartphone, so we are thinking that we can exactly predict his location. So I will go over step by step. So first one is collecting, extracting GPS data. So we have to gather all the GPS raw data from the smartphone. And as you know, we are going to use our smartphone and extract these, first gathering all these data and then extract it from the smartphone. It can be wired or wireless. And then we will going to pre-process these data for the machine learning. Like this. First, we will extract out of smartphone, and then we can pre-process that machine learning can get as an input. For example, day and time and position, something like that. Some text-based file will be the data that machine learning gets. And the second thing is machine learning. So the supervised learning stands for the learning from the labeled data. So this case, this is supervised learning. And as we said, there are many algorithms that we can use. And since it's supervised learning, the overall flow goes like this. There is an iteration. And we are going to use TensorFlow, as you may know. And this is assumptions that we are going to take. It can be changed in the future. The first assumption is we will restrict the area in the KAIST campus, inside KAIST campus. And also, we just focus on the daily routine schedule for weekdays, Monday to Friday, 9 to 5 p.m. And we will get position data every minute. So if we collect every minute position data, then it will be 500 points per day. But after we doing some machine learning things, if we think it's not enough for the training, that it might be enlarged. Or if we think it's enough or too much, then we can just make it smaller. So as I explained in the first introduction, it can be used as a prediction of the future location. So it can be applied to these areas. For example, forecasting location of criminals and the prediction location of missing trucks and the finding lost items. For example, your smartphone is missing, and then you ask your system that where would my smartphone be located, and then it can tell you that it might be near around here or there, something like that. So that can be possible, I think. So these are possible applications for our system. Okay, so we divided jobs and allocate to each person. So collecting data and extracting data and machine learning and plotting. Plotting is our additional goal. So we haven't determined who's gonna in charge of this item. But for the core goal, myself and Alessandro will be in charge of the collecting GPS data, and Pranjay and Hala will be in charge of machine learning part. So yeah, again, our main goal is to predict weekly routine of a person, especially Alessandro's routine. Okay, so this is schedule for our project. Today we had a project proposal, then we will have a mid presentation in the middle of November. So maybe we can possibly show you some midterm result at that time. So this is the references that we referred. Thank you for your attention. This is the end of the presentation. If you have any questions, please.
Right. So first question coming from another team.
네.
You explained your team developed an application and transport system. So how to connect an application and the system? This is application is there is in smartphone, and then transport system is in computer. So
Yes.
based on text file or other things.
The important thing is we need to pre-process the GPS data that machine learning algorithm can get as an input. So maybe it highly likely it will be the text file.
So gather the GPS data from smartphone and save the old data in text or other files, and then download it from smartphone to computer.
Yeah, it can be wired or wireless. Both ways can be considered.
Consider the wireless.
We don't know and we can't say right now, but it can be wireless or.
Any other question? No? TA?
So this problem is the location becomes a function of time.
Function of time and day. It can vary, but for now, we are thinking of that way.
So when you are doing the machine learning, you're gonna set day and time as a independent variable and location with
Yes, we can say that. Here, input and output.
So you didn't decide which algorithm.
No, not yet. So our technician will choose which algorithm to use. Yeah.
So are you gonna make a separate application? Or you gonna use the same algorithm? Or you gonna use the same algorithm?
Uh, here, input and output.
So you didn't decide which algorithm. So you didn't decide which algorithm to use. So are you gonna make a separate application? Or you gonna use the same algorithm?
Yes, possibly.
to extract the data?
That's not determined yet. Yeah, we're gonna find out some several ways to gather GPS data. So it's not determined.
So it can be done maybe without building a separate app.
Yeah, possibly.
You can just extract the data
Yes.
from the server.
Yes.
You and Alessandro are in charge of just extraction of data.
Mm.
So if you're not building the app, isn't there
Mm.
the job work portion is kind of
So you are worrying about our job location. Okay. So we will balance it if it's too small task. Yes. It's the first proposal, so
one thing that I thought is unrealistic is that the area is restricted to only KAIST. Why did
yeah.
you decide that? Like,
Uh,
they also
yeah, you can think that way. So I understood. But the thing is, our main goal is to finish up the proper target, proper goal. So if we are not, if we do not restrict our restriction, we thought it's not going to work properly. So in our short-term project, maybe it's the plausible goal for us to achieve. But as you said, if it has to be applied to the real world, it's too much restriction.
when you're doing the learning process, if Alessandro goes outside of the campus during that interval,
He's always in the campus. Yeah, I can say that. Yeah, he will be.
So I'm worrying that like if Monday there can be some time that he's outside, it's just assumption, and Tuesday different time, then the empty interval becomes different.
Yeah, you're right.
Maybe, but you're trying to find the correlation or some kind of pattern
Yes.
between the day and time and the location. So.
Yeah, maybe there are some outliers, like you said. But so we are going to collect as much as possible, so that we can find some meaningful patterns for Monday of Alessandro.
How often do you plan to extract the data?
Good question. We are planning to, if you see that, we will get position data every minute. Yes. So maybe it's battery consuming, but we will see.
But you intend to do this like a few weeks, right? Because you can't do this like only 1 week.
Yeah, a couple of weeks first, and then maybe until the end of the semester.
Kwon, okay.
Yeah.
Alright. Can I see the goal, core goal, and additional goal? The core goal is up to visualization, right?
Yes. No. It's except visualization.
Oh, visualization is additional.
Yes, because the core goal is to implement machine learning to the higher level. So
Then how can you use it for say predicting some kidnapping or Alzheimer's disease?
So what we are saying is we do not predict kidnapping, but if a child is kidnapped, then we just predict, for example, they're missing like around 1 p.m., then we can ask the system, where was the child around 1 p.m. on Monday? Then the system will answer. Then maybe police can investigate the case from that period of time or region, something like that.
My expectation was that the child is going outside of the usual trajectory.
Yes, maybe. Yeah.
It is sensed by the machine. And then the machine can automatically send the alarm to his parents, something like that.
Yeah.
Depending on how much it is off the trajectory, routine trajectory.
Yeah,
That is my expectation.
Yeah, that can be it.
So it can be a real-time alarming system.
Yeah, it can be, but our goal is not including that real-time alarming. So
Because you started with such a Alzheimer phase.
yes.
Right, I understand. Anyway, it can be a very interesting project. One more request is next time I hope similarly to the TA that job assignment per members.
Per members.
Right.
Okay, one member, one item.
One or more. Anyway, separation.
Okay,
Assignment.
we will.
All right. Very nice.
Thank you.
Additional question.
Yes.
So, when you're trying to decide the current location, do you think it is only affected by the time? Like, it can be also affected by the previous location. For example, where I am
Yes.
about an hour ago. So it can be a function of time and also the
Previous location.
previous trajectory.
Oh, that's a very good tip. So we will. Okay.
We should consider
Okay.
which factors affect the mission.
Okay. So this day and time is just the draft, and we just. Okay. Okay. Thank you.